In this video, I'll talk about how we can deploy a trained neural network. The last few videos, we talked about how we can label your data and then train it and verify the network. Now we'll see how we can deploy it to your own project. You can also find all the code from the series on GitHub, and you can find the link in the description. For this series, we will be generating a static library with MATLAB Coder and a deployable ROS2 node on a Jetson, which uses the available CUDA cores. But before we begin with code generation, there are some prerequisites that must be met. These prerequisites are listed in the script here, and the relevant documentation pages are linked as well. The first step is to ensure that all the required products are installed. The products listed here are for both static library generation and ROS node generation. But if you're only interested in, for example, static library generation, you can ignore the products that are specified for ROS node, and vice versa. Once you have all the products installed, the next step is to ensure that you have the right compiler. And MATLAB supports a variety of compilers, and the documentation to the list of supported compilers will be linked in the description. But if you want to check what compiler that you're currently using, you can run this code mex-setup. So this shows that currently it's configured to use Microsoft Visual C++ 2019 for C language compilation. But you can do the same thing for C++ by just running mex-setup C++. Again, for C++, we are using Microsoft Visual C++ 2019. This is the compiler that I'm using, and it's one of the recommended compilers. Once you have the products and the compilers installed, the next step is to install some external libraries. So, for example, if you're interested in generating a static library with MATLAB Coder, you would need to install Intel MKL-DNN, which is an Intel library that optimizes your code for deep learning. Similarly, if you want to use CUDA cores from an NVIDIA GPU, then you would have to install CUDA and NVIDIA cuDNN.
Makes sense.
Yeah, and there's also an option here to install TensorRT, which is another library that you can use instead of CUDA. And if you need that, you can install that as well. So once these external products have been installed, the final step is to ensure you have all the environment variables set. So this is so that MATLAB knows where to find these libraries. So here in this table, I have all the variable names and the example path and the description listed here. And right here it also says if this is for the static library or for ROS node generation. So for example, if you're interested in doing ROS node generation with the GPU coder, then you would have to install CUDA from the external libraries that we just saw, and then have that variable name defined in your system variables, and then point it to where the CUDA library was installed. And one point of note for CUDA installation is that you have to make sure you're installing the right version. The details of which CUDA version that you have to install based on the MATLAB version and the GPU you're using will be in the documentation that was linked.
So these paths here are just example paths, so make sure you update it to use the right version and the right path for where it's installed on your machine.
Exactly.
So what is a static library exactly?
So static library is something that can be used to link to an existing project. So let's say you're working on an autonomous car, an autonomous robot, and you need to do point cloud detection. And let's say you already have a lot of your code in C++, but then you're doing the point cloud detection in MATLAB. So what static library allows you to do is generate C++ library out of your code that you just made in the previous videos, and then you can package it and then get it to your environment where you did all your other C++ work, and then just link it like you would link any other library.
Amazing. So it just allows us to deploy it to an existing C++ or C project.
Exactly.
Amazing.
So the workflow to generate code is to first have your model trained and then saved, which we had already done in the previous video. So now we have to define the predict function and an entry point function.
So what is an entry point function?
Right. So entry point function is something that will call our trained deep learning model with passing in the necessary inputs so that the coder knows what kind of inputs it can expect.
Got it. So it like defines the entry point for Coder.
Yeah.
Got it.
The first step is obviously to have our predict function. Let me open it up. The predict function simply loads in the detector.mat that we saved in the previous video, and then passes in the point cloud and the intensity values, and outputs bounding boxes, scores, and labels. So it's just a function that uses the mat file that we had saved previously. And as we talked earlier, the entry point script is another script that just tells the coder how this function is going to be used. So if I open the entry point script, you can see that when you call that function, you're passing in your point cloud and your intensities. And then by running this, MATLAB will know what is the size and the type of the inputs that are going into this function. Again, this is important because in C and C++, you need to have your variables defined, and you need to know the size of your variable and also what type of data it's going to have.
And what type of data are we working with for this?
We are going to be working with floating point arrays.
Okay.
So you will see the data that MATLAB identifies in the next step. So to generate a static library, let me start by opening the Coder app, which is the app interface for MATLAB Coder. The first step is to tell it what function we want to generate code for. So I'm going to browse to the pillar predict function. Once we have the function open, we can click on next. This step is where you define all your input types, and since we have an entry point function, we're going to call that so that MATLAB can auto-define these inputs and sizes. This is my entry point. I'm going to open that and then choose auto-define input types. Here you can see that point cloud and intensities are of type single, and they take in a 32 by 1083 by 3 array for the point cloud, and then for the intensities it's going to be 32 by 1083. And what the sizes mean was already explained, but it's basically 32 channels of your point cloud, and we have 3 axes for the X, Y, and Z, and then 1083 is the horizontal resolution. Now that all the input sizes are defined, we can go to the next step. And this is to check for runtime issues. So before generating code, we want to make sure there are no issues with the MATLAB script, so that you don't run into issues after generating code. But if you look here, there's a pop-up that says that this code appears to be a deep neural network, and code generation for this requires you to enable code gen for deep learning. So to do this, you can click configure right here, or if you don't get this pop-up, you can also go to settings over here, and there's a bunch of settings here, but let me first go to the deep learning and enable it, because that is the main thing that we're going to do today. It's just like generating static library for a deep learning model. And the library that I'm using is mkldnn. Now that we have set the deep learning library, let me walk you through all the other options that we have. So the first one is the path, is basically the working folder and the build folder that you want the generated code to be in. So I'm going to keep it as the same as the project folder, so it'll just make a folder in your current directory. But you can change it if you want your code to go to a specific location. You can also optimize your code for speed, and you can go through these options. So some of that is to check memory integrity and make sure there's a saturate on integer overflow. Again, as you can see, if you hover through the options, it gives you more details on what that option means. And then you also have an option to automatically enable parallelization, and you can choose how many CPU threads you want to use. These are little advanced topics, but I'll be linking the documentation page for these in the description. And then when you come to memory, there's more options to enable either variable size arrays, or if you want to do dynamic memory allocations. And there's also an array layout if you want to do a column major or a row major, depending on what kind of application you're working in. And then there's some cosmetics like the code appearance. So one option is to have your generated code in different files based on how many functions you have, or you can generate all the functions into a single file. I'm going to keep it as generate one file for each MATLAB file, so it's easier to trace code. And If there are large constants, how do you want to store it? So that is also another option that you can play with. So you have like the byte size that you want to define. Again, this is important when you have an embedded device that you're going to generate code to, and then you don't have as much memory, so you want to limit how much of these constants are being saved as separate files. And for comments, there's an option to include MATLAB source code as a comments, so that when you're going through the generated file, you know that each function or each line in that code corresponds to this line of your MATLAB code.
Got it. So in the generated code, the comments will
Yeah.
be MATLAB code. Very
Yeah.
cool.
And there are a bunch of other options too. For example, if you want to use namespaces, you can define these here. And you can also generate C++ classes and enum classes from MATLAB classes and enumerations. The next step is debugging. So you can enable an option to compile in debug mode. And we always want to create a report, so I have that checked in. So this gives you a report at the end of your code generation. If there are any issues, that will be highlighted in the report. If not, it will show you that the code generation was successful, and you can see all the log for your for the generated code. And you can also have it automatically launch once it is generated. And this is also useful, especially for a static library. If you want to add some custom C code into the generated file, you can put in your custom code here, and it would just be generated on top of the C++ files.
Nice.
And yeah, you can also define additional include directories, additional source files, another library that you want to link. So there's a lot of options. These options will be described more in detail in the documentation. And all settings is just a view of all the other settings, all the settings that we just walked through. And once you have all of this set up, you can close this window and then check for issues. So this is essentially going to generate a MEX file and then run it to check that if there are any issues. And once it passes this, then we can just go on to code generation.
Nice.
So here we can see that a MEX file was generated and built, and it runs some test files with the MEX, and it detected no issue. So we're good on the code generation. So we can click on next. And now it's going to ask what kind of code that you want to generate. If you click on the build type, you can see there are a bunch of options. There's source code, there's MEX file, there's a static library, which is what we're going to be doing, and there's also a dynamic library and an executable. So let me choose static library, and then this is the name that our output file is going to be. So you can change it if you want it to be a specific name, and our target language is going to be C++. And generate code only will just generate the code but not build it. And but we want to make sure there are no build errors, so we're not going to check on that. And our interface style is going to be function. If you have a class that you want this to interface with, you can click on methods and then input the class name, so that your generated code will be defined as a class method rather than a function. But I'm going to keep it as functions for now. And there are some debugging options that you can use. You can also use a hardware board, like what you want to specify it for. I'm going to keep it as MATLAB host computer, but you can see that you can do Jetsons, you can do ROS, you can do STM based boards, and there's like some of the other options that I don't have the support package installed for, but it's available. So you can do ARM Cortex-A, Cortex-M, you can do a BeagleBone Blackboard. And there are like a bunch of options that you can use. So depending on your application, you can choose the one that best fits your need. And I'm going to choose automatically locate and install toolchain. But if there's a specific toolchain like CMake or Catkin or Colcon that you want to use, you can use that as well. So now that I have all the basic settings done, I'm going to click on generate code. This is going to take a few minutes to build and generate the code. So now that MATLAB has generated the code, you can take a quick look here, which would show you the generated code. It's the pillarpredict.cpp file. But a better way to view this is to view it through the report viewer. So I'm just going to click on next. You can see it here that it's as you can click on this to open the report viewer, but I'm gonna just hit next and show what the finished workflow looks like. So you have this. It tells you what function you generated code for, and then where the C code is generated. So actually, I can just browse to that location and show you how all the codes look like. So if you go into CodeGen and then lib, Prerequisites, and you can see all the files that was generated. Let me expand this a little bit so you can see the names. Yeah, you can see a lot of binaries that were generated, and you can see a bunch of headers and CPP files. So let's find our pillar predict. There it is. So yeah, you can open it up and then you can also edit the files here. This is not something that we recommend because the CodeGen usually optimizes it for good performance, and you don't want to be like changing stuff. It's hard to debug. So we recommend like changing your MATLAB file if you want some specific changes and then regenerating the code.
That makes sense.
But to make more sense of the generated code, you can also view it at the report viewer. You can open the report by clicking on the code generation report over here.
Makes sense.
And that opens MATLAB Coder report viewer. And then you can see this was our MATLAB pillar predict function. And then there's an option called trace code, which would trace each line to the generated code. So what you can do, if I click on this, it's going to scroll down to the section that in the generated code that corresponds to this particular line of code. So you can see that it is, if your network is not empty, it's just going to load that network and then make it true. So it's the same as what we're doing in MATLAB. And then the main is the detect function. So if you click on that, you can see that it's getting the point clouds and then outputting bounding boxes, scores, and labels.
Got it. So whether maybe you don't know a lot of C++ or you just don't want to spend the time scrolling through this to find everything, it's kind of a way to help you easily understand what's going on in the generated code.
Exactly.
Awesome.
That's the power of code generation, is that you write 15 lines of MATLAB code, and then you can generate C++ code that you can use it for your application. And this code is optimized for the libraries that you're using, so it's optimized for deep learning. All of this can be done in 10-15 minutes, and you already have a deployable code that you can put it into your robot or your autonomous car.
Much better than the already 220 lines of code we're looking at.
Exactly. So once this is done, you can close the report viewer, and then if you want to package your code to move it to a different application, you can just click package here, and it would generate a zip file of your project. Now that we saw how we can generate a static library, the next thing we're going to do is to generate a deployable ROS2 node. In this case, I've used a ROS2 node to publish a point cloud, and then we are going to subscribe to it in MATLAB and then generate code for it. So for example, if I'm building a robot and I have a LiDAR on top and I want to detect the barrels and the cars, I would take the point cloud from the LiDAR and then publish it as a ROS message. And then this function would basically subscribe to that message, take the point cloud, do the same detection that we did in the pillar predict function, and then publish the bounding boxes, scores, and labels.
So you said earlier we're doing this with Jetson.
Yeah. So I have my Jetson right here. It is not connected to a LiDAR, as you can see. I'm going to be publishing a static point cloud. So I'm reading a PCD file and then publishing it over a particular topic. But if you have a LiDAR, then you can just interface it with your Jetson and then publish live point cloud data.
But the overall workflow will be the same.
Yeah. So before I go into the ROS node itself, I want to show you how we can do the code configuration through a script instead of the app. The Coder app is useful when you want to see all the options available and set these options. But if you're familiar with MATLAB Coder, you can do the same thing as a script. Here I'm defining my coder configuration, and I have it set to an executable, so it's going to generate an executable. And I want to generate it as a ROS2 node, so I'm setting the coder hardware to robot operating system 2. And here I'm deploying it to a remote device, to the Jetson, and I want it to build and then run this code.
Makes sense.
As for the hardware implementations, I'm choosing an ARM compatible board because the Jetson has an ARM processor. And I'm going to enable some GPU configurations because the Jetson has an NVIDIA GPU, and we're going to be using the CODNN library. But if you have the TensorRT library installed, you can choose that instead of CODNN. And the last step is to define the IP address and the workspace where your raw source code lives, and the username and password. So this lets MATLAB SSH into your Jetson, transfer all the code built in to that particular folder that you have defined as your ROS2 workspace, and build it there so you can just use it in your Jetson. Now that we have the coder configuration set, we can write our own ROS2 node. I have the node right here. I'm going to name this as a detector node, and it's going to subscribe to the static cloud that is being published from the Jetson. It's going to publish the bounding boxes and the labels from the object detector. And we have some settings of the node here, so it's going to run at 30 Hertz. And here is the main body of the node, which is a continuous while loop. So what we're doing is we're going to read the XYZ data, or the point cloud points, and then we're going to read the intensity data. And we're going to pass both of these into the pillar predict function that we had already defined before. Get out the bounding boxes, scores, and labels from the prediction. We're going to populate the variables we have already defined with these prediction results, and then publish it using the send function.
And it's in a while loop because in robotics you usually are just waiting for the data to come in. You want to always be responding to new data, right?
Exactly, yeah. So as long as you get an input data, it would run it and then output the predicted results. So before I run the code, I'm going to add a breakpoint. This is to make sure that the code runs properly and the prediction results are good, and we can see all the cars and the cones that are being detected.
So just testing it on our way.
Exactly. And then I'm going to run the code. Now we can see that the execution is paused here. We can see the raw point cloud data that it's subscribing to by using PC show in MATLAB. And this is the point cloud that it is taking. And then let's see the bounding boxes. And we can take these bounding boxes and put it on the point cloud to visualize the prediction results.
Nice.
You can do that by using the show shape function. And as you can see here, it is detecting 2 cars, which is good, and the detection itself seems okay. And again, the bounding boxes are in the right places, so we know that all of this works. So let me go back to the script. I'll take out the breakpoint and then continue running it. Now that we have verified that the ROS node runs properly, we can go back and run that CFG that we had defined earlier and use that to start code generation. The CFG in the workspace, you can generate code by simply running codegen lidar infer and pass in the CFG with the _config option. So let me run this part. It's going to take a few seconds to generate the code, build, execute, and then transfer it to the Jetson.
That's a lot of steps.
Yeah. And as the process goes on, you can see all the steps being listed. And once it is done, you can close MATLAB, and then your node will be running independently in your Jetson. Now I'm going to close MATLAB and then open the console to SSH into the Jetson and see if it can publish the bounding boxes and the labels from the generated ROS node. Here you can see the topics that are visible to you when you do ROS2 topic list, and I'm going to echo the bounding boxes to see if the bounding boxes are being published. So now you can do that by running ROS2 topic echo bounding boxes, and you can see all the values of the bounding boxes being published. This is how you generate code from your train detector. So whether you've got an existing project that you're trying to incorporate your neural network in, or you're trying to deploy to a specific hardware, you've got 2 different options to deploy your network. To recap, in this video we saw how to generate C or C++ code from your MATLAB script using the MATLAB Coder. We started by ensuring all the prerequisites are met, and then we went on to generate a static library and a ROS2 node. We also saw that you can set up the coder through the app or programmatically. You can find a dedicated series on code generation in the link in this description. If you have questions or want to learn more, check out these community resources.